Thanks a lot, all of you, for joining today's session. Today, we're going to discuss about the extraction of iron through the reduction process. The question is, what is extraction of iron? Extraction is a kind of separation or isolation technique that is usually applied for separating the desirable component from its associated compound or associated mixture. And especially the extraction iron of metal is called metallurgy. Maybe some of you already been familiar with this word, metallurgy. Metallurgy is the process through which we can get our desirable metal from its minerals. You know that the metals or the non-metals, whatever we find from the nature, they are not found in their purest form. Usually they are associated, they are making bonds with other non-metals, with other substances. If we talk about iron, the iron that is used for the construction purpose and for other purpose, this iron cannot be found in the purest form on the earth. We need to separate the iron from its minerals. There are several types of minerals of iron, like it could be iron oxide. Most of the minerals are composed of iron and oxygen, sometimes iron and carbon, and also iron and sulfur. So iron oxide, iron carbonate, or iron sulfide, all these are some of the available minerals found on the earth. Now, if we want to get the iron, pure iron from these minerals, we need to go for some chemical processes. And these chemical processes are involved with the separation of our desirable metal. So any kind of chemical processes or physical processes that we are applying to get the pure metal from its minerals is called the metallurgy. In our theoretical part, section 117, we will discuss about the extraction of iron, most of the cases by using the blast furnace, electric arc furnace. And here we will just apply the same theoretical knowledge to get the free iron or metallic iron back from its compound. It is just a demonstration of that big process in a very small extent inside the laboratory. You can see here the name of this experiment is the reduction of iron to iron, because you know that iron is a transition metal and it can form the compounds by using its variable valences, valence 2 and valence 3. So here we have taken a compound of iron, which has iron 2, where the iron is at iron 2 ion, and iron 2 will be reduced to form iron free iron, that is called the metallic iron, by using charcoal block and blowpipe method. Here the charcoal block is just nothing. It's a piece of wood which containing the carbon, hydrogen and oxygen, and when we are burning the charcoal, when we burning the wood is converted into carbon. So it is a supply of carbon, pure carbon, and this carbon is helping us to reduce, to take the oxygen associated with the iron, and the iron will be free. And one more thing, I think you can remember the luminous flame and non-luminous flame in the case of Bunsen burner. When we were using the Bunsen burner to identify the metallic ion by using flame test, we use the non-luminous flame. But today we are going to use the luminous flame, because the luminous flame, it is one of the sources of carbon also. So from both sources, So the objective of this experiment is the understanding the concept of reduction, what is the reduction and how the reduction can be done, and the application of reduction definitely. And here the understanding the application of heat for a series of reaction. So this reduction process is carried out at high temperature by using the flame. And as I told you, the non-luminous flame, yes, sorry, luminous flame is used here because the carbon is required for this reduction process, and luminous flame is one of the good sources of carbon. So theoretical background, what we actually doing here, we took the salt of sulfate, iron sulfate, and mixed up with sodium carbonate. And after the mixing, the double displacement reaction. It is one of the classification of chemical reactions. In the case of double displacement reaction, one atom is replacing another one and other one is replacing another one. So here you can see the sodium is replacing iron and iron is and sulfate is replacing carbon. So in this case, iron carbonate is produced and sodium sulfate is produced. And this iron carbonate, when it is heated at elevated temperature, the iron carbonate is decomposed. Decomposition is another kind of reaction. After the decomposition, iron oxide and carbon dioxide is produced. And in this iron oxide is heated in presence of carbon black, pure carbon. As I told you, we have been using here the charcoal block, which is the source of carbon, and also the luminous flame. So both of the sources are supplying the carbon required to reduce this iron oxide into iron, pure iron. So these are the steps, three steps in this separation technique. The first, iron sulfate is mixed up with sodium carbonate and heated and producing iron carbonate. Then further heating, decomposing the iron carbonate into iron oxide and carbon dioxide. Then iron oxide is heated in presence of carbon black or free carbon, and this is reducing the iron oxide into pure iron and producing carbon dioxide. Apparatus, the demonstration. During the demonstration, you will find the list of apparatus. And procedure, mix iron sulfate and sodium carbonate on watch glass. Take the mixture in the hole of a charcoal block. Give heat to the block by using blowpipe. Blowpipe is used for changing the direction of the flame. Heat until getting some free form of iron. Separate iron by using magnet. Result discussion. After observing the demonstration, you can rewrite the result discussion by your own. So let's have a look what is the basic procedure for carrying out this experiment.
Today, I will show you how can we extract iron from the laboratory. So our experiment name will be extraction of iron by reduction process. Now, I will show you the apparatus that we are going to use in this experiment. This one, a spatula, wash glass, blow pipe. Maybe you have seen it in the jewelry shop. Magnet bar. This is the charcoal block. It is made by a piece of wood, mortar and pestle. This one is Bunsen burner. In this experiment, also we have to use two chemicals. One is ferrous sulfate, another one is sodium carbonate. Now I will show you the procedure how can we do the experiment. At first I have to take 1 spoon of ferrous sulfate, 1 spoon of ferrous sulfate in the mortar. Then I have to take 1 spoon of sodium carbonate or 2 spoon of sodium carbonate in the mortar. Now we have to grind it in the mortar and pestle, the sodium carbonate and ferrous sulfate. So it is already grind. So look at here, already I make it powder from, or I grind it. Now I have to place this mixture of sodium carbonate and ferrous sulfate in the charcoal block. So I am placing this 1 spoon or 2 spoons of sodium carbonate and ferrous sulfate mixture in the charcoal block hole. This one. Now I have to turn on the Bunsen burner. So Bunsen burner is turned on. Now we have to give heat in the charcoal block by using blow pipe and Bunsen burner. So look at very carefully how we will give the heat here. So look at here, you can see now it is become black color. That means our reaction is completed. Now we have to stop, give heat here. Now we will take it in the wash glass. You can see now it is a solid form. Now we have to make it powder. Okay, it is almost in powder form. Now we have to place here a magnet. If it is attract with the magnet, then we can say we have struck iron. Now look at here. Yes, yes, it is attracting with the magnet. You can see. Oh, look at it. Yes. So it means our experiment is done. Now we will see the reactions that happened during giving heat in the ferrous sulfate and sodium carbonate mixture. During heat, ferrous sulfate and sodium carbonate reactions with each other and form ferrous carbonate and sodium sulfate. If you give heat continuously, then ferrous carbonate will be decomposed and it will be formed ferrous oxide and carbon dioxide. Carbon dioxide is the gas, it will go to the atmosphere, only remain ferrous oxide. This ferrous oxide again reacts with carbon and form iron plus carbon dioxide. Again carbon dioxide is the gas, it will go to the atmosphere, only remain iron. Now question is that from where you will get the carbon? You will get the carbon from the charcoal block, and iron will be detected by the magnet bar. Why it is called reduction process? If you see at the first stage of the reaction, ferrous sulfate, in the ferrous sulfate oxidation number of iron is 2, but at the last reaction if you see iron plus carbon dioxide, here oxidation number of iron is 0. That means in the beginning iron has oxidation number 2, but at the last it has oxidation number 0. That means oxidation number of iron is reduced. That is why it also known as reduction process.